Hey there, welcome to my YouTube channel. Make sure to like and subscribe. Now, in this video, we want to talk about the NHL shift data. We want to clean it, we want to transform it. Now, in the last video, we worked with the play-by-play data, and in this video, we want to work with the shift data. So we already loaded the shift data from the NHL API into our database. We did that a few videos ago. So you can see here that there is already a table called shift data. The problem is that it's not really set up in a way where we can usefully work with the data. So we need to transform it, we need to clean it somewhat. But before we get started, let's just create a new script. And I'll make sure to save the script and put it below in the description. So the first thing we want to do is we want to just add a new tab where we can put in our script. Okay, so let's start off just by looking at the shift table. So we'll just say select everything from shift and always end with a semicolon. Okay, so it took a while to load because we are loading all of the rows, and there's more than 1 million rows of shift data from the 23-24 season. So let's just limit this a little bit for the next time we do a call. Okay, so what do we have in this information? Well, we have the game ID, we have the end time, we have the period, play ID, shift number, start time, and team abbreviation. One thing I want to show is, so if we sort by shift number, you can see that there is a lot of shift numbers zeros, but all of these have the same start time and end time. So it's actually shifts that doesn't exist because there's no, so there aren't actually any shifts here, is what I was trying to say. So we want to just exclude all shifts where the shift number is 0. So let's just start off by saying where shift number is larger than 0. So now we are excluding all rows where the shift number is 0. So now if we start from, you can see that 1 is the first number. Okay, so now we can clean the data just a little bit. So let's just say we want to keep the game ID column. We want to keep the play ID column. Let's keep the shift number column as well. Team abbrev. Let's call this one team instead. There's no need to call it anything else. And then let's change how the start time and end time is written. So right now it's written in a text format, but we want to have it in seconds instead. So let's just try and calculate that. So we want to take the first 2 digits, the first 2 characters, multiply by 60, add the last 2 digits, the last 2 characters. So let's start off by doing that. Left 2, that's not correct, left, and then we want to take the left from the start time column, and we want to take 2 characters, and then multiply by 60. And then we want to add the right side, that's not correct, the right, also from start time, and also the last 2 digits, the last 2 characters. So, and then we want to rename this as start, And then we'll just do the same for the end. So let's just copy this. Say end time. End time as end. Let's see what it does now. So it says starts at 0 seconds, ends at 1200 seconds. So all of these players are just goaltenders, obviously, because they started the period and then they played the entire period. This is fine. It does what it's supposed to do. However, we also want to so when the second period starts, we don't want to start it from 0 again. We want to start it from 1200. So we'll just say plus period times 1200, and then we want to minus 1200 because we don't want the first period, we don't want the start time to start at 1200. We want it to start at 0. So this should work. And then we'll just do the same for the end time. And say run this. And again, because we only have 1,000 rows, we can just try and say don't limit it and run it. It will take just a little bit longer, but it should work. So now we have the end time. So you can see there's one game where the first shift is only 2 seconds long. I don't know what happened there. Maybe a fight or something. You can sort it the other way, and you can see some games ended very late. Obviously, this is a playoff game with multiple extra periods. Yeah, so it works, and this was all that I wanted to do at first. So now we have a table with the game ID, the play ID, the shift number, the team, and the start time and the end time. Okay, so this is our first step in this video. So we want to just create a new table, and we'll just call it create table, and we'll call it shift underscore temp 1. So then once we're done with our script, we'll just delete this table again. But now let's just run it. And that's it. So the next thing I want to do is the problem with this shift data is that we have no idea of knowing what the string state is. We don't know if it's 5-on-5 or 4-on-5 or 5-on-4 or whatever. And as you could see, some of the player shifts in the shift table goes from 0 seconds to 1200 seconds. So obviously there's a lot of penalties in between those 1200 seconds. So we need to cut it into smaller pieces and then determine how many players was on the ice for that specific shift. So the first thing we need to do is we need to define shifts in a different way. So I'm going to say every single time a player either gets on the ice or off the ice, we'll create a new shift. So this way we're sure that that we can define the string states afterwards. But we need to first define the shifts as every time a player either gets on the ice or off the ice. So the way we'll do this is we'll just create a new table where we'll take the game ID and the start time, and then we'll append it to the game ID and end time, and then we'll find all the unique values, and then that will be our shift table, our shift index, so to speak. So this way we're making sure that every time a player gets on the ice or a player gets off the ice, a new shift starts. So you might think that whenever a player gets on the ice, a player automatically also has to get off the ice. But that's not necessarily the case, especially in the newest seasons, where I think they started tracking player shifts automatically from the video feed. So sometimes a player, or oftentimes a player, gets on the ice a second or 2 seconds or even 3 seconds before the player gets off the ice, because it's tracked via video, I think. So this means we have to add shifts whenever a player gets off the ice as well. So maybe it's the same time, maybe the player gets on and off in the same second, maybe they don't. Okay, so let's just see. So what we need to do is we need to say select, and then we set the game ID, comma, the start value from shift temp 1. So this just gets all the situations where the game ID and start is. So then we want to union this. This means we want to append a table where we take the game ID and the start value, but we don't want to just take the start value, we want to take the end value. And then we need to rename it to start, because then we have the same name of the two columns, so you can append them. And then just end it here, and let's see what happens if we run this. Okay, so now it took the game ID, and then it took the start values and the end values and put it all in just 2 columns. Now, I would have thought that there would be a lot of duplicate values in here, because obviously multiple players get on the ice at the same seconds. But apparently when you do a union, it also works as, it also removes all duplicates. So these are just the unique combinations of the game ID with the start value and the end value. So these are our shift index. So this is just 2 columns where every time a new player gets on the ice or off the ice, a new row is started. Okay, so far so good. So let's just create a new table. Let's say create table shift temp 2 and create that. So there are a little bit more than 500,000 unique shifts in this season. So let's, in the next step, try and give them all a unique shift index number. So how do we do that? Well, we're going to use the, well, actually, let's start off by, let's just say select everything from shift temp 2. So actually, let's start off by finding the end time as well. So right now, we just have the start value, but we also want to have the end value. So how do we do that? Well, we're just going to take the number from the next row. And they're not sorted correctly here, but let's make sure they are sorted correctly. We could even just say order by game ID, comma, start. So now we are ordering the data correctly. So let's see what happens here. So now they are ordered the first shift, then the next shift, then the next shift, next shift, next shift, next shift. So we want to have the end time. So the end time is obviously just 0, and then it ends when the next shift starts. So the end time should be 28, then it should be 30, 32, 33, and so on. So in order to do that, we can use the lead function. So it works like this. So you will want to take the start value from the next row. So this means that because we say 1, it takes the next value. If we said 2, then it would take the value 2 rows down. And then whenever there isn't a value to take, so that would be the very last row, we want to put in a 0. Okay. So now it just takes the next value, but we wanted to not, if a game ends and a new one starts, then we don't want to take the next value. In this case, it doesn't really matter because the next value of the next game would, by definition, always be 0 as well. But it's better to do it this way, just in terms of understanding what's going on. So how do we do that? Well, we can use the over. This is how we define it as a window function when you use the over functionality. And then we'll say partition by game ID. So this means that every time a new game starts, then we start over, so to speak. So whenever a new game starts, then it doesn't take the next value. Then it will take the value that we defined here as 0. Okay, and we need to order it by game ID and start value. And then we'll call this one end. So this should work. So now you can see it takes the game ID, and then the first shift starts at 0 seconds, ends at 28. This one starts at 28 and ends at 30. And then we can go all the way down until the new game starts. So let's see here. So the last shift of the game starts at 3,598 seconds and ends at 3,600. So this means that the very last shift here, we actually want to delete this one. So whenever the end value is 0, whenever a new game starts, we want to not include those rows because the duration of this one would be minus 3,600. Doesn't make any sense. So we'll just delete these whenever the end value is 0. But we'll do that in the next table. So we'll just end it here and say create table shift temp 3 and create it. And that's it. So the next step is to create a shift index. So we're going to give it a unique key that is unique to each shift. So we'll just start off like we always do by select everything from shift temp 3. Let's just say 1,000 rows. Okay, so we have the table here, and now we want to add a shift index. So how do we do that? Well, we can use the row number function, which is also a window function. So the row number just counts 1, 2, 3, 4, 5, depending on how we define it. So again, we're going to partition by game ID so that it starts over whenever a new game starts. And then we can use that as our shift index. So let's just see here. So we'll just say row number, and you have to add a parentheses, and then say over partition by game ID. We want the row number to start over. We want the row count to start over whenever a new game starts. And we still want to order by game ID and start. Yes. So now we're just counting rows. 1, 2, 3, 4, 5, 6, 7, 8. We can just test it out. And you can see the name is quite stupid. But now we're just counting, but then when a new game starts, it starts from 1 again. So right now it's not a unique key. So we need to add the game ID. So we'll just say plus game ID times 10,000. So now it takes this one and then multiplies by 10,000 and adds this one. So now it's a unique index, and we'll just rename it to shift index. So let's see if it works. It counts 1, 2, 3, 4, 5, 6, 7, 8, and then all the way down, and then when a new game starts, it starts from 1 again, but now the game ID changes, so it's still unique. Okay, so the last thing we want to do is we want to remove all the rows where end equals 0. So we'll just say where end is larger than 0. And now it should work. We can see that the last shift now should be the one that ends at 3600. Yes. So everything works, and we'll just say create new table. Shift temp 4. Run the script. And that's okay. So the next thing we want to do is we want to combine our player shifts with our shift index. So we want to take the shift temp 1, which is our player shifts. Let's just try and do that. Select everything from shift temp 1 and see what we got here. That's not correct. Let's say shift. And you can see here, so this is our table with the game ID, player ID, the team, and the start and the end. So what we want to do is we want to, instead of having this shift go from 0 to 1200, we want to add a new shift every time a new shift index. So between 0 and 1200, there's a lot of shift indexes. So we want to add rows for every shift index. So we'll do that by joining the two tables together. Okay, so we'll just say as, let's call it S1, and then do a left join with the shift temp 4, the last table we did, shift temp 4, and we'll call this one S2, and then we'll join it on, well, first of all, the game ID has to be the same. So we'll say game S1 game ID has to be equal to S2 game ID. Okay. Then the start value of our player shift table has to be lower than or equal to the shift index start value. So S1 start has to be lower than or equal to S2 start, and likewise the S1 end has to be larger than or equal to the S2 end. So basically this takes all the shift indexes that is between 0 and 1200 seconds and adds rows for each of those. Okay. So this should work. We don't want all of the tables because then you'd have 2 start values and 2 end values, and you would have 2 game IDs, and wouldn't make any much sense. So let's define what values we actually want here. So we want to have the S1 game ID. We want to have the player ID. We want to have the shift number. We want to have the team. Then we also want to have the shift index. From the other table, and we want to have the start value and the end value from the other table. So we want to have S2 start, and we want to have S2 end. And I think this is it actually. So let's see what happens if we do this. So now for every player, again, this is a goaltender. So these are all the shifts he had between 0 and 1200. And you can see there's a lot of shifts here, where before it was just one row. But it works. This is what we want. So now when we create this table, we'll see that this is a very large table because before we had a little bit more than 1 million rows, but now that we add all of these shifts with the more detailed definition of what a shift is, the table should be a lot larger. So let's just try and say create table shift temp 5 and run the script. Okay, so this took a little bit longer, and as you can see, there are now 6.55 million rows in our player shift table. So it's quite a large table that we got now. Especially if we want to add even more seasons, not just one season, we'll be working with very large data. Okay, so let's just go on from here. So what we want to do is we want to find out what is the string state of each shift in our shift index table. And there is no easy way to get that information. But what we can do is we can count how many goaltenders are on the ice and how many skaters are on the ice, and then use that to get the string state. But to get that information, we first need to join our player shifts with our players table to know if the player is a goaltender or a skater. And then we also need to join this table with the schedule table to know if the team is playing at home or away from home. Because we need to get the string state from the perspective of the home team and the string state from the perspective of the away team. So that's just how we need to set it up. So we'll just start, as we always do, select everything from shift temp 5. And then let's just run this. And then we want to join. Let's do a left join. And then we want to join our players table. So we'll say players. Let's just name this one S. And then we can name this one P for players. And we want to join on the player ID. So S player ID has to be equal to P player ID. And this should work. So now whenever there's an identical player, so now whenever you have player ID, it looks it up in the players table and adds additional information. But we also want to join on the game ID with the schedule table. So let's just do a left join more. So let's say schedule, and we can call this one SC, and we'll join on S game ID has to be equal to SC game ID. So let's just try and run this first. So now we have a lot of information in this table. So for every player ID, it looks up player information, but the only player information that we're actually interested in is the position. And the only information from the schedule is the home team and away team, because we want to see if the team is equal to the away team or the home team. Okay, so far so good. So let's write out what columns we're interested in. So we're interested in the game ID from the original table. We're interested in the player ID. I don't think it really matters if you put in a small or big or lower or uppercase character, but let's just keep it like this. Then we want the shift number. We want the team. We want the shift index. We want the start and the end value. And then we want the position, but we're not really interested in the position. We're just interested in knowing whether the player is a skater or a goaltender. So let's do that by writing a case function. So let's say case when position equals G, then we'll say 1, else it's a 0. And then end the case and say this is goaltenders. So basically it's a column that says if the position of the player is a goaltender, then it's a 1, otherwise it's a 0. And then we'll do the same for the skaters. So we'll just copy all of this and say if the position is G, then we'll say it's a 0, otherwise it's a 1. And then we'll call this column skaters. And finally, we want to know if the team is the home team or the away team. So we'll add yet another case function. So we'll say case when team equals home team. Then it should be then we'll say home when team equals away team. Then we'll put in away, else we'll put in a blank and end this and say this will call venue. Okay, so this is what we want to run. Now I already know that it's gonna make a mistake, but let's just try and run it and see what happens here. So everything works except for the venue. So apparently I think there's a space after the team value. I don't know why exactly, but I think there is. So we need to rewrite this so that instead of saying team equals home team, we can say left team, comma 3. So now it just takes the first 3 characters of our team column and sees if that's equal to home team. And we'll do the same for the left team, comma 3. And then let's try and run it. So now it should work. So you can see here that Florida is the away team. So this is what we want our table to look like. And this is quite a large table because this is still 6.5 million rows. But let's just try and create the table. It will take a little while again. Let's say create table shift temp 6 and just run the script. All right, so now we have our table, very large table with information about how many skaters and goaltenders there are on the ice for the home team and the away team. So now we want to add that information to our shift index. So we'll do that by doing a group by. So let's just try and say select. We don't want everything, but we want the game ID. We want the, now we are not interested in the player ID, but we want the shift index. And we want the, well, we still want the start time and the away end time. So let's say start and end. and then we want the venue, and that's it. So we want to say from the shift temp 6, and then we want to group by those columns. So we'll say group by and copy these. So what this is doing is it takes all the unique combinations of game ID, shift index start, and venue. So let's just try and run this fast. So now it gives us just a list of all the shift indexes from the perspective of the away team and from the perspective of the home team. So if we sort by shift index, you should see 2 values for each shift index. One for the away team and one for the home team. So now what we want to do is we want to count how many goalies are on the ice and how many skaters are on the ice. So we'll just say some goaltenders, and we'll call this one as goalies, and we'll say some skaters as skaters. So let's try and run this. And this is it. So now we're just counting how many goaltenders are on the ice for the away team in this particular shift and how many skaters are on the ice in this particular shift. Okay, so so far so good. The next thing we need to do is we need to find out how many goalies are on the ice in total and how many skaters are on the ice in total, because then we can figure out what the strength state is. But for now we need to create just a new table based on this. Create table shift temp, was it? Yeah, it's 7, and then just run this. Okay, so now we run this and you can see there's 1.1 million because we have the shift index where we got 550,000 different shifts in this season, but now we have each shift index 2 times because we have it 1 time for the away team and 1 time for the home team. But let's just try and add the total amount of skaters and the total amount of goaltenders. So let's just start here. So let's say select. Actually, we don't want to include all of the columns. We don't need the. Actually, let's just keep it all. So let's say everything from shift temp 7. Let's just try and run it. And now we have it here. So what we want to add is we want to add all goalies for this shift index and all skaters for this particular shift index. So how do we get that? Well, we can again use a window function. So we can say sum goalies and then say over partition by shift index. So now it sums all of the goalies in the goalies column for this shift index. And we can order by, I don't know if this is necessary really, but let's just put it in there. So let's say order by shift index. And we'll call this one total goalies. Now we'll do the same for the skaters. So we'll just say some skaters and call the column total skaters. So let's try this. And this is it. We can see here, so now we have the number of goalies for the away team, the number of goalies for the home team, and we have the number of skaters, but we also have the total skaters on the ice and the total skaters. So in this case, it's clearly 5 on 5 because there's 5 skaters on the ice for the away team, 5 skaters on ice for the home team. So with this information, we can say that the string state is 5 on 5 for the very first shift. So this works as it's supposed to. So let's just create a new table and then we'll do the string state. So create table shift temp 8. Let's create it. And that's it. So now we'll figure out what the string state is for each shift index. So we'll just say select everything from shift temp 8. Let's do that first. And then we can say let's just get the game ID. Let's get the shift index. Let's get the start time, the end time, the venue we can add. But now instead of having all of these, we want to create a case function where it calculates the string state. So let's do that. So let's just go down and say case when, so when there are 2 goaltenders on the ice, we want to have the string state based on the number of skaters on the ice. So we'll just put in when total goalies are larger than or equal to 2. Obviously, there should never be more than 2 goaltenders on the ice, but the shift data in the NHL API is not perfect. So sometimes there are listed more than 2 goaltenders on the ice. So let's just say whenever there are more than 2 goalies on the ice, we want to get this string state based on the amount of skaters on the ice. So I hope this makes sense. So let's say when total goalies is more than or equal to 2, then the string state is the number of skaters versus the number of opponent skaters. So we'll just create a concat, use the concat function, which just puts different strings together. So the first part of the string should be the number of skaters. The next part should be let's put in a V. And then we want the number of opponent skaters, but the number of opponent skaters has to be total skaters minus skaters. Okay, so this is when we have two goaltenders on the ice, or more than two goaltenders, which in theory shouldn't be possible, but in the data it is sometimes. Okay, so the other situation is when the number of goalies is 0. Then we want to define that as an empty net 4 situation. So then the team has an empty net. So we'll say when goalies equals 0, then we'll put in ENF for empty net 4. And when the amount of goaltenders for the opponent team is 0, then it's an empty net against situation. So then you're playing against an empty net. So that's the case when the goalies is equal to the total goalies, then the opponent team must by definition have 0 goalies on the ice. So we'll say when goalies equal total goalies, then it's an empty net against situation. And that's it. So now we can say, we can end the case and call this one string state. So let's see if it works. I think that's it. Yes, let's see if it works. And you can see now you have the string state from the perspective of the away team and from the perspective of the home team. So you have 5-on-5, 5-on-5, 5-on-5. Then at some point it should be, so here you have the away team is playing 5-on-4, and naturally the home team is then playing 4-on-5 in this particular shift. So this seems to be working. So the shift data is not perfect in the NHL API. Let's be honest about that. So let's just test out a few things here. So let's say we only want to look at the different kind of string states. So how do we do that? Well, we can group by string state and just add the string state. So let's try and say, oh, actually, we need to create the table first. So let's say create table shift temp 9 and run it. That's it. And now let's try and say select string state from shift temp 9 and say group by string state. So now it just looks up all the unique string states. And 5-on-5, 5-on-4, 4-on-5, empty net against, empty net 4, 3-on-5. All of these looks okay. But then you start to see some very, very weird string states here. So playing 10 against 6, I don't remember seeing that ever. And there are some weird string states because the data in the shift data from the NHL API is not perfect. There are mistakes. And it's also has to do with players getting on the ice before players getting off the ice. But let's just try and say, instead of just looking at string state, let's try and count it as well. So let's say count string state. So if it's just one shift, that's the problem. Then it's not necessarily a huge problem. So let's just count it, and also let's look at the duration of the shift. So let's say sum of the end value minus sum of the start value. So this should give us the total duration at each string state in seconds. So let's try and run this. Okay, so we can sort it by the duration. So you see here that by far the most ice time is being played 5-on-5. So this is a good thing. This is what we would expect. Then you have a lot of 5-on-4, and you have some 4-on-4, some empty net situations. You have some 3-on-3. To me, it's a little bit surprising that there are more 4-on-4 hockey than 3-on-3 hockey, considering all overtimes are 3-on-3. But I suppose this is correct. I don't have any reason not to believe it. And then you have these 6-on-5. So these are not empty net situations, because if there was no goalie on the ice, it would be so in this case, 6-on-5 would be an empty net 4 situation, and 5-on-6 should be an empty net against situation. But that's not the case, because there is at least 2 goalies on the ice. So my assumption here is that these are situations where a skater got on the ice before a skater got off the ice. So the actual string state is probably 5-on-5. So we want to, and this is too large of a number just to ignore it. We have to take these situations into account. So I want to change this to a 5-on-5, because that's very, very likely the case here. Obviously, this is an estimation. This is what we suppose it's like, but we don't actually know it. And you have a similar situation here. 7-against-5 is probably 5-on-5. Now this one, on the other hand, 4-on-6 and 6-on-4 is most likely 5-on-4 hockey, where one skater got on the ice before a skater got off the ice. So we want to change these, and then you have these very weird situations. 10-against-9, it's likely a problem with the data. But in our data, I think we'll just define all of these weird situations. We're going to say it's probably 5-on-5, because most hockey is being played 5-on-5. So we will have these edge cases where it's 4-against-6 is most likely 4-against-5, where there's just one extra skater on the ice. But other than that, we'll just say that everything else is 5-on-5, because I think that's the best estimation. It's not perfect, but the data is not perfect, so we have to do some kind of estimation here. So we'll try and change these string states so that they are as correct as possible. So let's try and say, so let's try and select, let's say everything from shift temp 9, and say that's it. Oh, we forgot the from. And say this is it. So let's try and change the string state whenever it's something weird. So in order to do that, we need to do a case function. And we don't want to have the, so let's just say game ID shift index start end venue, and then we'll do our case function. Case when, okay, so the special cases are when it's, so let's say when string state equals 5 on 4, or string state equals, let's say 6 on 4, or when string state equals 7 on 4. So in these cases, I'm going to assume that the actual string state is 5 on 4. So that's our estimation. So let's say when this is the case, then we'll put in 5 on 4. Okay. Then we'll do another one when it's the other way around. So let's say when string state is 4 against 5, 4 against 6, or 4 against 7, then it's most likely actually 4 against 5. Okay, so now we'll do the same whenever the string state is 5 against 3. 6 against 3, or 7 against 3. I don't think there is a situation where it's 7 against 3. I don't know actually, but let's just put it in there. Then we want to change it to 3 against 5, 5 against 3, and then we'll do the same down here. Just change all of these. Okay. And then we have all the other situations where we don't want to change anything, but we have to put it in there, and then in the end, everything else will be 5 on 5. So let's say when string state equals 3 on 3, then it should be 3 on 3. So we don't want to change that. And we'll do the same for 4 on 4. So let's just put that in there. 4 on 4 should be still 4 on 4. And let's do the same for the empty net situation. ENF should still be ENF. Empty net against should still be empty net against. And then finally we have the 3 on 4. Should still be 3 on 4. And 4 on 3 should still be 4 on 3. So I think we have them all now. 1, 2, 3, 4, 5, 6, 7, 8. That's yeah. So I think we have all of these situations now. So everything else we'll say is 5 on 5. And this will be our new string state. We'll just say as string state. So again, this is not perfect by any means, but it's the best estimation we can come up with. So let's one more time create a table, shift temp 10, and run the script. And that was it. So let's just try and say select everything from shift temp 10. Try and run it. And now you can see it looks pretty much the same. And the only thing we want to change now is we want to have the string state not in one row, not in one column, but in two columns, because we want the shift index in this particular table to be unique. So we only want to have the shift index of the first shift in one row, and then say string state for the away team and string state for the home team, instead of having it in two rows. There are some advantages to having a unique key when we get to the visualization part. So we want to set this up in a way where we have just one row for each shift index. But obviously then we need to have two string state columns. So we'll set that up. So how do we do that? Well, we need to do yet another case function. Let's just start off by putting in game ID, shift index. There's a comma too many here. Start time, end time. And then we don't want the venue, but instead we want a case function. Let's say case when venue equals away, then we should put in the string state. Else we will put in just a blank value and say this is our away string state. And then we'll do the same for the home string state. So we'll just copy paste, say home, and then this will be our home string state. So let's try and run this. And now you can see you have the away string state and you have the home string state in two different columns. Now we need to put it together and remove all duplicate rows. So I don't know if you can do this in one step, but let's just create yet another temp table. So let's say create table shift temp 11, run it. And that's it. So the final step, actually there are two steps left, but the next step and second to last step is to create our shift index table that we are actually gonna keep. All of these temporary tables will delete after the fact that when our script is done, we'll delete all of those. But let's create our shift index table. So this one is, so let's just start off by saying select everything from Shift Tab 11, run it. So now we want to group by game ID, shift index, start and end. And then we want to take only one of these values, and then we don't want to take the blank values of these two columns. So how do we do that? Well, we start off by using the group by function. So let's say group by game ID, shift index, start and end. Then we'll just put these up here as the columns. And then we'll take the max value of the away string state. So these are ordered alphabetically because it's two strings. So the minimum value will always be the blank value. So we don't want to take that one, but we want to take the max value. And we'll just call this one as away string state. And then we'll do the same for the home string state. So let's just copy it, put in home instead. And let's try and run it. So now we only have one row for each shift index. So the shift index is now unique. And if we go in here, we can see the away team string state is now 5-on-4. The home team string state must, by definition, then be 4-on-5. So this is what we wanted to create. So now we created a shift index table. So let's say create shift index. So this is a table that we're going to keep. Create table shift index. Let's run it. And you can see there are 552,000 unique shifts. And this table we can use for our later visualizations. And the final table we need to create, we still need to have a player shifts table. And we actually created this table all the way up here. There's just some extra information here that we don't want to include, but we want to take data from the shift temp 6 table. So let's go there and say select everything from shift temp 6. Let's see what's in here. So we have game ID, play ID, shift number. I don't really think we'll keep this one. I haven't used it for anything yet. So let's just ignore that one. Actually, yeah, let's ignore it because this is going to be a very large table. So we only want to have as little information as we need. So let's keep the play ID, let's keep the team, let's keep the shift index, start and end time. We don't want that because we have that in our shift index table anyway. Goalie, skaters, let's leave that one out. We do need to know the venue. Because we need to know that when we need to find the string state from our shift index table. So what we need is we need the play ID, we need the team, we need the shift index, we need the venue. And this is it. So Again, this table is a 6.5 million rows table. So we want to keep as few columns as possible. So we could include player names or things like that, but there's no need to have that information because we can just get that information from the players table anyway. So we'll just say create table, and we'll call this one player shifts. So that's what we wanted to build. So now we have a shift index table and we have a player shift table. And these two tables we can use to build our visualizations later on. But it is a little bit complicated to get to this point because we need to have the string state, and that's not easily found from the shift data. Now, as we talked about, there are some mistakes in the shift data or some weird things going on from time to time. I think the estimations we made here are okay. I think the data is now, there are some minor mistakes along the way, but I think it's so few mistakes that it still makes sense to use this. Now we are mostly going to use the shift data to get time on ice. But whenever we want to know if an event is the string state in which an event was taken, a shot or something like that, we'll take the string state information from the play-by-play data rather than taking the information from the shift data. Because I trust the string state in the play-by-play data more than I trust this method of getting the string state. That being said, I still think it's okay to use this to calculate string states at different, or calculate the time on ice at different string states. Obviously, there might be a few mistakes, a few minor differences from the true value, but all in all, I think it's going to be okay. So let's just create this table, and then the last thing is we'll just drop all of the temporary tables. And that's it. So now all that's left to do is say drop table shift temp1. Then we'll just copy this. A few times, say 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So now we can just run all of these. And now all the temporary tables have been dropped. So we have a script now. So if we were to load data using this code from a different season, change this to shift and load different data into our original shift table, then we could just rerun all of this code, and then instead of creating new tables at the end, instead of creating shift index table, we would just say insert into, and then it would just add the new data at the end of this table that was already created, and we could do the same for this one. So this way you could just use this script to add new data from new seasons, from other seasons. And then it would drop all of the temp tables after you run the script. So my guess is a full season worth of data would probably take around 10 minutes to do all of these calculations, and that's it. So it wouldn't take that long to get shift data for all of the seasons in the past. So that's how you can use it. I'll save this script here and put it in the description below, and that will be it for now. So goodbye.